it's Gadget UK here again, back for part 2 of the Commodore C16 repair. So where we left off in part 1, this board came from Sparks UK. I think he bought 5 or 6 of these boards. They were junk boards. He managed to get a couple of working ones, I think, and one of them was the one he sent me. Well, he sent me 2, didn't he? So very, very, very much appreciated. I actually have enjoyed working on this. It's a nice little machine. So in part 1 we did this CPU adapter here to fit a 6510, because the original 7501 or 8501 were known to fail. You can't really find them as spares, and they sell for like £50 each. Sparks was telling me the other day, 50 quid. That's ridiculous. Whereas you can get a 6510 for, I don't know, 10 or 20 quid probably. And we got a TED on there, which was provided by Sparks UK. That's an R3. I got a couple of R2s there that came from Alex, so another huge thanks to Alex there. And then Daniel Mantione provided me with some PLA kits, and we replaced the PLA with a modern GAL replacement. So that's going to be long-term level compared to one of the original Commodore PLAs. The PLA, by the way, it does address decoding, just like it does on the C64. You know, it's providing all the chip selects. It does generates the RAS signal, I think, and the MUX signal and stuff. But yeah, it's very, very, very much like the way it was in the C64, and seemingly an Achilles heel like they are in the C64. So we socketed up the other RAM, because one of these was already socketed. So in this video we're going to upgrade the RAM. We need to get the tape port back on this. We need to get a missing joystick port on. It was missing the 6.8 volt Zener diode there, which I believe is used in conjunction with this TIP 29 transistor here to power the tape port. I could be wrong about that, but I'm just guessing. Because there's no other reason to have another voltage on here. Why would we need the 6.8 volts? And as you saw in part 1, this boots and works without that diode at the moment. So yeah, I suspect it's for the tape port. Now, also in part 1, we couldn't use a C64 keyboard. I worked out that the matrix is configured differently. This chip here, when I was talking about this chip, it was my own thought process that made me question this just now. And that is, I was talking about this chip saying, no, you know, Commodore decided to take one of the ports out of CAA and stick it on here, and it's a bit weird. Why would you not just use the CAA? Because they probably had loads of CAAs in stock. And then it suddenly struck me. I'm like, well, hang on a minute. The pinout seems very familiar to me. It looks like a
74LS245.
And I was like counting the pins and stuff, and then I just went actually looked at the actual pinout side by side, and I suspect that's a
LS245.
like they did with the other MOS chips. I just suspect that's like a Commodore branded HC, you know, an LS, probably an LS
245.
So I'm going to socket this. I haven't even got a keyboard to test, but what I do know is I think on my keyboard like 456 or 567 do actually work at this stage. I'm going to socket this up, remove it, stick a socket there, and try
a 74LS245.
Because I've got a theory that that's going to work. Now, the nice thing that it does work, obviously, it's not a custom. You can just swap it nice and easily. But, I mean, I paid £5 for one of these in the previous part there, thinking this was bought before I worked out it probably isn't. But some of them are even more expensive. I've seen someone selling them for like £15–20 each. You could add some fresh soldering flux like that, just to assist desoldering. Anyway, let's just see how we get on without adding any additional. Just in the solder sucker again. This is one of the problems we're using with a solder pump. You can see like the shards sometimes come out and get stuck back on the pin you're trying to solder. Yeah, the solder's largely removed from that. May need to give them another go with the solder pump there. Now bear in mind I've got a replacement one of these coming anyway, because technically you could, you know, damage with a bit of heat. Let's just see if it's anywhere near ready to come off. Yeah, just rocking sideways, forwards, backwards, etc. Hopefully I won't lose a pad. Yeah, there we go. So the chip is off. Clean it around there. You can see it's a bit dirty around there. And we'll get a socket on. So just checking the pins on the socket. Pin 1 is to the left here. So I get the notch on the socket the same way. Made sure you need to use the dowel actually, because just one or two of these here are just a wee bit blocked. See if that'll go on. Yep, there we go. There we go, that's alright, it's just dirty, needs a clean. But right now I'm eager to test it. Now it's a wee bit risky, I could kill Ted or something doing this. Yeah, that doesn't work. Yeah, so it's not a 245. I've not given up thinking about that keyboard IC. It's bugging me. What you should really do when you want to test something like that is not just test the theory and go, oh, it's the same pin out and the same pin count, let's just stick something in there. Look at it on the logic analyzer, because then you'll be able to confirm whether it's behaving the way you think it's, you know, whether it represents the chip you're putting in there. I'm wondering if like the outputs are inverted or something like that, or I don't know, there can't be very much difference. And my thought process there, pin 19 is the chip select, yeah? So that's the equivalent of the output enable on a 245, and pin 1 down here, which is the direction pin on 245, I think, is the read-write. And it sort of makes sense, doesn't it? You've got data connections on one side that go to the CPU, and then connections on the other side that go to the, you know, the matrix, yeah? So, I don't know, for all intents and purposes, it kind of does look like a 245, but maybe there's a latch or something internal to this. No idea. Post your comments down below. I mean, I could look at the VHDL for this, because obviously someone will have reversed all of this stuff previously. There's probably, you know, an FPGA core for the MiSTer or something for this. I can have a look at that. But, yeah, that's curious. I thought it was a 245, but clearly not. Unless, let's say they swap the directions of these around. There could be something like that going on as well. Let's move on to this. Let's get this port off. And do the same with the joystick port. So I think one of these is a 7-pin mini-DIN and one's an 8. Yeah, I forget which way around they are. So I've ordered some cables so I can make my own adapters up here, which I'm going to need to do if I want to test the Datasette and test the joysticks. And actually, because I bought a pack of 2 of each, I can make a test, you know, the harness to go with the test ROM. You saw me use the test ROM in the previous video, where you can create a, you know, a loopback harness. And flip it over. Just to see if we can remove this. Well, there's ferrite beads on the way there. Patience is everything, really, when you're trying to remove something like this, because obviously you don't want to damage the connector. Yeah, it was the first pin on this side here that was not completely free, so if we just now carefully look one way and the other, and try and pull that out. It's almost there. There we go. So that looks alright. So yeah, we'll clean the inside there with the toothbrush and stuff. We'll clean it with a little bit of vinegar perhaps as well. Anyway, that's off. And we didn't lose any of the pads off though. So we're now installed on the board we're working on here. So the exact same thing I showed in the previous video, we'll just go over that gently with the fiberglass pencil. So just inspecting the pins there, they look okay. It can be quite hard to try and align this. This is the problem here, it's getting all the pins all aligned. And if you've got the smallest bits of solder on here, obviously it's going to struggle. It's a bit tight at the back, there we go. So that's there. But the key is making sure everything's through here, and it is. Yeah, so we'll have a clean around there with cotton bud and IPA. Exact same process on the joystick port. I think the next thing I'll do here is just pull the power thing out there, and I'm just going to clean up this switch because it's like really crusty switching it off and on. Now this may not make a difference, I don't know, but we'll get some contact cleaner in there. It perhaps needs taken to pieces and re-greasing. Yeah, it just feels crusty there, it feels like it wants to stick in the middle. Whilst I wait for the other parts to arrive, let's upgrade the RAM. So we socketed this in a previous video, this socket here, that one was already fitted. That was the original RAM there. Yeah, so I've got what I think is an equivalent here, the -15s. You may be able to see the part number there. So let's give those a go. Now if we put these in, it should just work as 16K to start with. These are 64K instead of 16K, 4 bits each. That's why I have 2 to give you 8 bits. But yeah, that should give us 64K. But the way it's mapped with the connections underneath here, the additional address line or 2 are, I think it's 2 probably, isn't it? Because if there was 1 address line, that would double it to 32K. 2 address lines would quadruple it from its original size of 16 to 64. So there's 2 additional address lines going to each of those that we need to deal with. They're probably just like grounded or 5 volts or something like that. But if we switch that on, that's good news. That shows that RAM is not completely dead. It's being tested as a 16K RAM, and it's showing 16K, so we next need to deal with those 2 address lines. I'm just testing some additional RAM chips I've got here as well. Yeah, and those work as well. So those look like Intel ones or something. They've got an I there, might not be Intel. But yeah, I think those are 21464s, and those seem to work okay. So the simple solution to the additional 2 address bits that we need, they actually go to the 257s here. If you remember, when I was probing these, I found one that was stuck high, and I said it was wired to 5 volts, you know, the bottom pin on these. And that's correct, because if you think about it, the exact same chips and the exact same amount of RAM, 64K, is used on the C64, and all the connections are used there. On these 2 here, a pin on each is hardwired to 5 volts. So it's A14 and A15. Dave over at Time Mouth Software's done a guide on this, and it was the first thing that came up in the search results, because I was trying to work out which. I knew I needed to cut the address bits on, cut the 5 volts going to these 2 multiplexers here, and connect them up to address bits on either the CPU or TED. I just wasn't sure which bits. Let me just consult that guide again. Hang on a sec. Yeah, it's A14 and A15. So yeah, the first thing we need to do is cut the 5 volts going to each, the 1 pin on that and the 1 pin on that. It was one of the end pins, wasn't it? Yeah, pin 2. Yeah, so pin 2's on this one here is tied high. So we need to break the trace that feeds that. On this one up here, it's the 3rd one along, from the top left there. Yeah, so 3rd from top left. So there are a few ways you could approach this. The pin that needs cutting on this one here, if I flip this over, you can see it's joined up to VCC there, so I could cut that connection. But obviously, you then can't revert it. One thing that did cross my mind is I might remove this one, put a socket on, and then I can bend the pin out on both of these here, bend the pin out here, because the other point is the pad that joins, the trace that joins the pin there to VCC seems to be on the top side. So that's a bit problematic. So that was the first thought. I thought I'll just pull this pin out of the socket so it's not in the socket, and join wires up. So I think that might be the easy thing. Depending on which side of the thing here, I could join it on here. This is the nice thing with this. I can have the wires for those 2 address lines on here. And obviously when you look at the pin out, don't look at the 6510, because its address lines may be mapped. I'm trying to think. No, they can't be. They must be the right way around. Yeah, so you could go off the pin out there versus the pin out down here, because it's it's a 6502. The address lines are going to be correct there. They're going to be mapped between this to the right pins here, despite the fact an address line down here might be somewhere over there on the other side, if you see what I mean. But yeah, that's the approach I'm going to go with, I think. I'm going to now desolder that, get a socket on, bend the pin out on each of those, and have 2 wires going over here. Now there are numerous techniques you can do. You can push into the pins from this side here to snap them off, but that leaves the pins in a bit of a bend sort of state, and I want to get this chip back into a socket. So I'm just going to put a little bit of flux here on both sides. Clean this off in a minute. I'm just going to use a bit of braid. If you're not careful, sometimes you can lose some of the solder mask doing this. Still a bit stuck, but I think one of the pins was bent over on that side. There we go. So we may have lost a pad there, haven't we? Yeah, we have. Oh, we lost 2 pads. Yeah, so full disclosure, we lost that pad. It's not used, and you can see I put a wire onto this trace here through there. So I'm just going to stick it. I'll stick a tiny bit of green nail polish on that, just on that little bit there. Use this tool to apply it. You won't be able to see it. And then the socket will go on, and obviously I'll solder the wire on the other side. So I'll clean up later. It's this one here. You can sort of see where it comes out there, and it goes down to resistor pack here, and you can even got join. So yeah, that's fine. Right, so I'll show you how I've wired this. Obviously we've got that socketed pin 2 here is out on this one and soldered onto that wire there, and it's going into the PLA here. I'll show you where that corresponds on the CPU socket. That's what you want to check. And the other one, obviously the third from top pin here, is out and soldered a wire on, and it's going up to there on the PLA. And if I test those, that top one there goes to the corner. Can you see that? Pin 21, and the other one goes to the pin next to it, 22. You've got 20 down here. It's a 40 pin socket. 20, 21, 22. So yeah, that should be it. It should be 64K now. Whoa, 64K. Yeah, the part where it flashes coloured screens, that takes a lot longer. Yeah, so that was it. Dead simple. It doesn't really matter which way round you get those 2 wires either. All you're doing is just, widening the address range there from 16K to 64K. It doesn't really matter which address bits go to which chips on the RAM. That is of course important with ROMs, because it's expected in a certain sequence. With RAM, random access memory, it's yeah, there's no relation, what's the word? It doesn't matter about the order of address lines or data bits for that matter on RAM. You could, rewire the data bits in a different order on DRAM. It would make a difference, but it would on a ROM. Now, Commodore C16 is now technically a C64. Well, not really, but you know what I mean. It's like, yeah, if you go off the model number, it's now not a C16, it's a C64. So final tidy up on the RAM there. You can see use a piece of heat shrink on both of those. Just looks a bit tidy. Obviously it is attached to the PLA, but I expect that's probably going to outlive the likes of the rest of the system. And booting up to basic, we've now got 60K free. Fantastic. So what else have we got to do? We can't do anything else just now until I get the keyboard. I think once I get the keyboard, I can then test the serial and stuff, and I'll see if I can make an adapter for maybe the Datasette and the joystick ports. So I think it had to be done. I had to get a case and a keyboard for this. I might try some acetone on that crap. What we can do is press it up from the inside, melt it together, but push the pieces together so it's almost seamless, and then maybe a tiny bit of acetone. But the label's good. The actual overall state of the shell is in really good condition, and the keyboard as well, actually. I'm pretty pleasantly surprised with that. Now the question is, are there any screws? Oh, there are. He's actually provided the 3 screws there. That's good. That was my only concern. I've got screws from the C64 because it uses new ones for the C64. I sourced some of those from the service manual when I was working on some C64. So anyway, let's just get the screws out of this. Don't over tighten these screws, whatever you do. I'm guessing it's the same as the C64, where they break from. The one thing I'm missing is a plate for the side there. So, I don't know, I might ask around on my Discord, see if anyone's got one. Sparks UK might be the guy to ask. Let's just carefully lift it up, see if we can unhinge it. There we go. So that's the keyboard disconnected. Oh, I've got the screws in here as well, look. So I don't even need to source screws for that, that's great. We're not going to screw the board in just yet, because we're still waiting for the Xenon diode. But let's get these screws out. The other sad thing with these cases is people using these for C64s. They're making nice, like, custom black C64s. And yeah, alright, points for, you know, style there. But why would you want to do that? It's like a poor C16 is, you know, never going to see light of day again, is it? Because you've cannibalised its parts. But then again, not all C16s can be saved, so I guess there's always going to be a surplus, maybe, of extra shells. Anyway, let's get the board in there. We'll clean this up before we finally assemble, but you know what? He's done a pretty good job cleaning it, it's not too bad. So this means I can reuse this ESD bag, actually. You know, my original plans with this were to keep this and use it as a test board. What I might do, crazy as it sounds, is get the other board working. You've seen how bad that other board is, it's missing everything, but I'm going to have an extra CPU. I've got a spare PLA, I've got a couple of TEDs, I've now got one of these, that's just arrived as well. We socketed that up earlier, so that's going to be easy to test that. So I mean, that other board, yeah, it's missing some of the passives and things, and the transistors and regulator and all that, but we could backfill those. It's missing the ports, obviously, but I reckon I can get that other board up and running as well. So there might be part 3 to this, I might actually attempt to do that. I can use a C64 power switch as I discussed in part 1, you know, there is a way I think I could get one on there. We've now got our ports on here, and I can't connect anything up to that. What we can do though, is connect the SD to IEC here. It just needs 5 volts and ground. So I might be able to do some sort of clippy, sort of on-jobby, where I, you know, put some croc leads from the, technically just the 5 volts, clip somewhere onto the 5 volts, join up to the SD to IEC, and assuming that this keyboard works, and we don't still have a keyboard fault, let's get this up, then we can try and load some games and demos. So yeah, let's give it a go. We'll connect the power lead up as well, I think. Where's that now? So yeah, I forget where the power LED goes already. Black to the centre. Ah, power. Yeah, we still got this power thing, haven't we? So I'll have to stretch the croc leads. Yeah, now it's in the case. What I'm going to have to do is just shift it over here a little bit. Let's just do that. Yeah, you can just about see here, I've got a clip here just to hold these leads. So yeah, anyway, we'll just sit it here. Right, so we've got basic up. Let's just try the keyboard. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. QWERTY, A, S, D, F. Obviously, need to test all rows and columns, but you know what? I'm going to call that a success, I think. Just test some of the ones further afield. Yeah, everything is working. So, that is really good news. Let's try shift run stop. Hey! Right, here's the SD to IEC. So yeah, the serial connection, I'll just switch it off before I kill the blooming thing. Yeah, the serial connection is going to easily plug into our serial port, I think. Let's just plug that in. Yeah, there we go. So the only other thing we need to do is power it, and this is where this connection here comes in. It's a single connection there. So I just need to work out where the 5 volts is. I'm guessing it's going to be one of these end pins, just based on where it is there, maybe the second one in. I'll test that on a C64 motherboard, and then I'll just wedge something in there, I think, and join a croc clip to 5 volts on here. And then I think we should be good. Obviously then need to take the SD card out, make sure the file browser's on there for the C16. I'm just going to go do that now, actually. And some disk images for the C16. So the bodgiest bodge ever here, I've worked out it's the second from end right pin here, so it goes into the C64 like that. You can see I've just wedged a diode in, just because it's good enough to make a connection. Croc clip onto the 5 volts here, and just like sit that there. If you watch the front of this as I switch the Agilent on, see the LEDs? So I've got power. So the file browser is FB16, so I think I'm assuming the device numbers and the commands and things are the same here. Load FB16. 8,1. Nope, it's not doing anything with the drive. I think I need to go away and read about the commands on this because it ain't like a C64. Yeah, as you can see, I've got it working. I'll explain how in a minute. This is a demo called Chromatic Admiration. Very cool. But anyway, I'm glad the disk drive is working. So of course the one thought I had was the CPU we were using, 6510 here. This has 6 I/O bits. It's got a separate P bus, you know, if you like, which comprises of 6 bits. The 8501 or 7501 has
7 bits.
Yeah, that bombed out at the end. I'm not sure if that's just finished. Yeah, it's thrown me back to the basic screen. But anyway, I wondered if it was those extra bits, and I looked at the schematics, and I can see they go to the tape port. Now I was aware, because we've got the jumper that sits under here, related to the tape thing we need to still deal with. I wondered if it was that, but I couldn't see how that would interfere with the serial port. But one of the bits does go there, I think, via an 06. The 06 actually here is what buffers the signals, and I checked that with a logic probe. That was the first thing, thinking, is there going to be a fault with that buffer? But I couldn't really see anything. The logic states look correct for the input versus the output all the way around the 06, so I thought, well, let's just try this chip here from Lotharac. Whilst it's a standard 6502A, it's got the CPLD, which is probably doing the address decoding for
all 7 bits.
It must be, because otherwise that wouldn't work. And I just plugged it in, tried the disk drive command again, and it just worked straight away. So that's what it is. Whether we can get this working with the disk drive, I'm not sure. We may find when we do the tape mod for that, to get the tape port working, that the disk drive works as well as a result of that change there. But anyway, that seems to have solved that. It may be a limitation with this mod here, that if you use a fixed 6510, maybe you can only use the tape side, you can't use the disk drive. I don't know, I need to research that a little bit more. I'm pretty new to this. I've seen some of these things on other people's channels in the past, but you know what it's like, some of it goes in one ear and out the other. Not everybody always covers every scenario. The video I saw, someone may well have fitted one of those 6510 adapters there and then just got the tape port working and never used serial. I honestly do not know. But if I type load FB16, that's what I've called the file browser there, comma 8, 1, it hits the SD to IEC, and then we can just type run. And there we go, there's the familiar file browser that you'll have seen before. So it's very cool. It took me a while to find the cursor keys. They're in a totally different position. Instead of being down here, yeah, it's different, isn't it? This is the thing. So yeah, I always thought this was laid out the same as a C64. It isn't, actually, on inspection. There's lots of differences. But it is a strange business decision by Commodore, because if they'd stuck with the original keyboard layout, they probably could have saved themselves lots of costs and stuff, but I don't know, one of the aims with this seems to have been to make it a little bit different, you know, with the different ports and things. So you've got to buy Commodore accessories, you have to buy a different keyboard from Commodore, etc, etc. Nevertheless, that is working. So let's have a look at the C16 folder. Let's try another bit of homebrew here. Because of the PETSCII, it doesn't display ASCII very well. You've got to stay away from uppercase characters, I think, when you're naming them on your FAT32 card here. So Threve. That's another demo. Let's load that. It's a PRG. You can see the LEDs here. It's still loading. Woohoo! Look at that though. It's like the colours are so much better, aren't they, on the C16? I think it would do higher colour depth, but you don't seem to be stuck with some of the colour, well, the colour palette limitations you had on the C64. I could be wrong. I'm not sure if that break up there on the left hand side blocks here is correct. That one obviously is, but is that intentional? Might have to watch a video of this demo. Yeah, there we go. It says 1.7 megahertz, 121 colours, 2-tone sounds. No SID needed. There we go. After much trial and error, I've managed to use some DuPonts to go from the C64 keyboard here to the C16, and it is working. So if I just flip the keyboard over and press return a few times and have type QWERTY, press shift and Commodore key, goes lowercase, shift run stop, loads. So about an hour and a half later and several swear words, we have a messy adapter here. I'll squish these wires in a minute, but yeah, so the idea is you can plug this C64 keyboard on there, and this can just plug on to pin 1, the same orientation as this here, onto the C16. So let's give that a try. It does mean I'm undoing this. I took some photos, but anyway, let's just pull all that off. If there are any issues, I might be able to just, well, I will be able to just work them out by looking at the schematics. So male to female DuPonts like that are super useful. So I'll connect it on there like that. Why is that in the way? That's it. And we'll connect our C64 keyboard up the same way. It's technically not very resilient, this, because it's soldered side on. But anyway, let's now give that a try, and hopefully it will work. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, hang on, yeah, 9. I thought we didn't have 8 for a minute. QWERTY A S D F G H J K L M. Yeah, and then M's obviously in the next row. Yeah, so that's working. Let's press return. Hey, fantastic. Yeah, so no awards for beauty or anything there. That is an eyesore. But it works, and it just means I can test C16s this way just using the C64 keyboard. Right, let's get the Zener diode. It's here, 6.8 volts. So the band designates the cathode. And just like a normal diode, the band on the board there at the bottom is the cathode. The difference between a Zener and a normal diode is it will switch in forward direction like a normal diode, I think. And I measured these in one of my meters. It's like 0.78 volt forward drop, but they have a reverse switching voltage, 6.8 volts. Yes, the band wants to go down towards the bottom here. I'm not sure both holes are unblocked there. Yeah, they are. Yeah, so I just need to simply get it through the hole. Yeah, and I'm going to push it in, and then I'm going to bend it over like that, away from this, and we'll solder it in a position like that. Right, so the next thing I'm going to do is build a joystick port adapter. So you can see I've got a male 9-pin D type connector here, and I've got a hood for this. I had to buy that separately. It didn't come with the... You can get them together, but yeah, I just bought those separately at different points in time. Anyway, and actually this is one of the ones from Allison Shellis, so huge thanks to Colin and Nathan for those components way back. Yeah, so that's going to be the joystick end. So our 9-pin, Kempston / Atari style joystick is just going to plug into that, yeah, and then we're just going to adapt to the DIN. So this one is a 3, 4, 5, 6, 7, 8-pin. It's an 8-pin mini DIN. So the way these come is you can just pull this off here, and then separate the, I think, 2 pieces of plastic here. Yeah, so it can be a bit fiddly to put together once you assemble it. But then you've got this metal shield here. This comes off like this. And that should just leave the centre piece here, look, with the pin. So we'll just pull that out. We can reassemble that in a minute. And we just need to make sure that the connections here are joined up. I've got a wire here, it's an old HDMI lead. The cores are a bit thin and flexible in a HDMI lead, but it's going to be clamped. You'll have a cable grip somewhere in here that grips it, so it's tight there, so it can't, as you flex the cable, it won't pull the connections off. And similarly, in this side here, 2 of these that grip, you screw them together around the cable like that, and then it will hold it at a predefined, predetermined position like that, so that you don't break the solder connections off when you wiggle the cable. So 10 minutes later, joined up, down, left, right, fire, and ground. The nice thing with this HDMI cable here is the cable is just like Kynar. You can just heat the end with some solder flux and it just melts straight back. So I didn't even have to strip those. And if you try to strip those on a short length like this, you'll pull the wire through. From prior experience. So anyway, the next thing we need to do is obviously get it in here and put the little clamp there, so that's going to be in approximately just the right position to hold that. You could just have, just do that and then lift it up and rotate around maybe. There we go. And then we get the other screw through here now into the other thread. Let's just do that. It sits on this edge here, look. Yeah. And then this is going to go into this area here. So at this stage now, you could tighten this up and try and tighten it so that you pull it right down to the very bottom, maybe push the wire up a wee bit so that it can't be pulled. There we go, all screwed together. So I did cut a screw down to the correct length. You can see the end of it looks a bit squished there. And on this side I put some washers just because I didn't get it quite the right height. It was stuck out just a little bit and I was getting cheesed off with filing it down. But yeah, I've ordered a few of these and every one of them has come with one screw missing for the hood part there. Anyway, the next key thing is obviously I've stripped some more wires, well not stripped my wires, cut all the excess ones off, just left the 6 wires I need. Feed them all through there. This is important, trust me, if you forget to do this bit, you will be seething because you have to then undo all the wires. It's pretty tight this, as you can see. I'm not even sure I can get that on. Yeah, you'll have to undo all the blooming wires. Yeah, I'm going to need to put some lubrication here, some Vaseline or some oil or something. I'll just use a bit 3-in-1 oil and all that. I can slide that right down past the connections here, solder the points on here. The second one on the 2 on their own there is the yellow. Yeah, and I've made a note of which colours go to up, down, left, right, blah blah blah. I'll show you the diagram in a minute. Just solder that on. Once that's done, the other bits just clip around that and then this slides over. Right, so as you can see I slid this right down there, soldered all the connections on. It looks like it's not going to grip, but this plastic thing here is the thing that does the cable gripping, as far as I can see, because it clips on sort of like up here, and then it's the bottom part of that that grips down here. So anyway, we need to clip this on the right way. There's two little gaps. There's 2 little gaps there for that side. This one's got a larger centerpiece, so it's going to go there. I'm going to try and hold it all together like that. That's it, that's correct. And then we need to get these on. Now there may be a notch here that corresponds with something on that, I'm not sure. You've got this here for the notch, so you want that lined with this point here, I think, actually. Just see if we can turn that. Yeah, we can. Yeah, I think that's right. I think if we just slide this upwards. Right, full disclosure, I had to take it back to pieces again. The white wants to go to the select signal on here, not the ground. Anyway, the pin out will be correct in a minute. So yeah, in order to slide this back, the point where the notch is here, you've got to lever something under it and try and pull the housing back, so I had to put some oil on it again. So I had to take it to pieces again. Yeah, test it before you assemble the housing. So I'm going to need to heat it with a bit of hot air, I think, just to try and get that plastic to sink back down. But anyway, now it should be alright. What I did there, the setting time, obviously the selector's joined up instead of the ground, so you select it to the ground to go to each, when you press the button, it joins the select pin up to the direction, or the fire button. But then it was moving on its own again, and I was like, what's going on, how is it moving on its own? And I did some connectivity tests, like 3 or 4 of the pins were all joined to the shield, and I'm like, well, there's nothing connected to the shield, so it must be the metal, that metal piece of stuff that clips on, just touching 1 or 2 of the connections around the, where the wires are. So I just put some tape around it, put the metal on, put the plastic piece on, slide it all back together again, and here we are with jack tape loaded, and hopefully if I press fire, hey, I can go left and right. Before it was just going right on its own like that and flickering. So yeah, there we go. Woohoo! I can now play some of these games on the C16. Interesting first screen. Got to wait for the time thing to run out at the top here. As it runs out, the blocks will come down. You can't actually do anything until those come down. Unless it's glitched out, I don't think it has. So yeah, they seem to have, I think they've mixed the levels up on the C16 version. I don't remember the C64 version. Hang on a minute, they are coming down. Oh wow, we have a problem. So let me show you this. Layer 1, go down, left, right, up. And if I unplug the joystick carefully, hang on, yeah, port 2 is a bit tighter than port 1. Plug it into port 1, up, down, left, right, fire. And you can see the adapter there. Yeah, I redid it because this connector here was bugging me. I've been in and out, in and out, in and out, and the top was all, you know, the plastic piece was all warped and stuff here. So I just redid it with the same connector. There's like £1 each, so it's not the end of the world. I'll probably buy a couple more of those. It's useful to have a couple of spares, but we've now got a joystick adapter there that works on both ports. So the diagram for the joystick port is from zimmers.net. It's pretty simple. You've got the 9-pin D-type connector here, so port X, port Y can ignore. You've got right, ground, left. You can ignore the 5 volts, down, fire, and up. So you've got the directions and the ground on a normal, you know, Atari or Kempston style joystick. Now the issue I had was with the ground. You don't actually use the ground. On a normal joystick, what you do is you connect the ground to each button. You know, as you press a button, it connects ground to that particular pin. On this, the way this works is there are 2 select signals, one for each joystick port. You know, you've got 2 of them come from the board somewhere, each separate connections that go to pin 8, I think it is here, on the mini DIN. Yeah, the 8-pin mini DIN, and it's that you need to connect to a particular button to activate it, if you like, not the ground. So originally I just wired it as you would do a 2600 or Atari style joystick here with the ground, and I ignored the select signal, and actually that's what you need. So yeah, you want the select signal to connect to the ground point here, yeah, so that whenever I press the button, let's say select is connected to the button. And then just, you know, fire to fire, left to left, up, right, down, etc. So it's pretty straightforward to do. And you can see, you know, the orientation here. There's like a gap between those 2 and that one on that middle row there. And that's the key, really, when you're looking at it. You know, if you look at the print, sometimes there's print on the back of the actual connector, and it gives the pin number, shows you where 1 is, etc. They may even be numbered individually in the back of the connector. But if you look at it in relation to this here, you can't go wrong, you know, in terms of that gap there. So adding this bit in at the end, the annotation there saying don't slide this housing over until you've watched the whole video. Well, there's a few reasons so far. One of them was obviously had the wiring wrong. Check it before you slide the housing over, make sure it works. But the second one is, once you've slid over, you can't get it back off without damaging this, so you've got to make sure it's 100% right. And then the final part here is, you can see this plastic edge, it's pretty thick, yeah? So if I was to put this into this port, can you see? It barely makes a connection. It's like literally just touching the edge there. So what I would do is cut a specific amount of this off all the way around, the same on the solid plastic inner part there, just like a millimetre or so, and then it will make a better connection. So I need to, I might show you this in the next video as part of some of the stuff, because there's quite a lot of stuff in this video, but quite a lot more in the next video as well, including a more in-depth look at the 6502plus4 from Lothrak. But it is important you deal with that before you slide the housing over. So the next thing we're going to do here is make a cable up using the same old HDMI cable here. So I've just got 6 cores, and that's all we need. We've got ground, 5 volts, then we've got like sends, motor, something. We've got 3 ones for the tape, I forget what they are. Things like play, record, sense, and something else. Yeah, so you can see I've got this little PCB here from eBay. It was pretty expensive. It was about, I don't know, £4 or £5 for that, believe it or not, which is ridiculous because it should be pence, probably, you know, 50p at most. But it's got these little breakout things here. We can solder the wires on. I need to get the cable pretty short. You know, these wires are pretty short here, because what it's also got is these 2 holes here. So you could encapsulate it in, you know, a thing that's got the screws, you know, plastic housing. But you could also put a cable tie or something over there. Right, after trying a few different things, I found this in my collection of fixtures and stuff. I keep things from plugs and plastic fittings, all sorts of mounts and things like that. And the spacing there is almost perfect. Yeah, what we can do is, I've got a 9-pin D-type connector here. They're only, I don't know, £1 or something like that. I got that many years ago. I'll replace it though, I think, because it's always handy to have 1 or 2 of those spare. And it will fit like this. The cable will obviously be on the underside here. We'll do it this way around. And it's going to go over there, through the hole, and there's enough room there for a nut, as you can see, and the gap under this means that I can put it there, hang on, squish it like that, put a nut on each side, and I'll have a cable grip. And there you go, there's the first part of that. So those are all wired on there, they're not shorting or anything. And I've made a note of you know, which colour is going to which pin. Well, pin 1 is here, you've got ground, VCC, motor, read, write, sense. Yeah, so yeah, the next thing to get the DIN on, before I do that, I'll get a piece of, well, I don't know, I can get a piece of heat shrink over that first actually and shrink that maybe, but I think I'll wait until I've completed this. This isn't the right type of cable, again, you know, HDMI cable, it's not designed to be completely, you know, flexed and flexed and flexed, but it's not going to be flexed really, is it? It's just going to be plugged in and then over the Datasette or the SD to AC adapter there just to get the 5 volts. But if you wanted something where you're going to be flexing it a lot, you would want a thicker gauge of wire, without a doubt. So again, I've slid the housing on first, and I did just put the screwdriver in there and twist different ways just to widen this ever so slightly, but it's still really stiff. So I might need to put some oil or something on there before I can slide that all the way up. But anyway, I can now solder this onto the mini DIN here, get the heat shrink on, and we're done. I've soldered the mini DIN on here. I will stick some tape around the connections there before I put the housing on. But you know what, learning what I learned about the joystick adapter, I am not putting the housing on here until I've tested it with an actual Datasette. So anyway, I'll put the parts here, you know, the 2 metal bits and the 2 plastic bits into a bag, and I'll just leave this with this. But we can test this now in terms of the SD to IEC. It should power the SD to IEC. I might try and get some heat shrink around that, and obviously we'll get some heat shrink around this bit. I'll do that in a minute. We no longer need this thing, you know, this was just like, this side here was just bodged into the thing there. Well, we don't need that now, do we? We can plug this in. The 2 pins go at the bottom. And then this should now, hang on, I've got to get this right way. Yeah, this is the 5 volts, so it goes to the side where there's 2, not 3, goes that way. There we go. So, all being well, when I power this up in a minute, once I connect everything back up here, the light should illuminate when we cycle the power. I'm not sure I saw that then. Did that flash? Yes, it did. There we go. So the power connection there is working, but obviously, as I say, I'm not going to put the housing on this bit here until I've proven an actual Datasette works. So using the Datasette adapter for that, the keyboard adapter for the keyboard, and the joystick adapter for the joystick, we can load a game. FD16, Commodore 1. Yeah, so I'm very pleased with this actually, because all these little adapter things seem to work. And it means that, as you'll see in part 3, when I get the other board up and running, I'll have one of these myself, and I've also ordered another keyboard shell, which you'll see in the next part 2. Sorry, not a keyboard shell, you know, like a case for it. So technically the only thing I'm lacking is another keyboard. If I got another keyboard, then I would have a complete C16 myself, because obviously the first one, this one, will be sold. Some of these games are just amazing, they really are. Mastertronic game this, Gunlaw. So you'll see straight away how hard this is. Just watch, I'm bound to die about 5 times in the first. Look, I'm dead already. Yeah, the way the screen scrolls, you don't have any chance to react to anything. You've got to kind of move forward a bit, back a bit, forward a bit. If someone comes straight on you, you're knackered. Yeah, it's like Commando, isn't it? Oh god, I've killed a few. Oh. I can imagine as a kid I would have been impressed with this maybe when I was about 9 or something, but oh, it's like you can't even avoid things. Their bullets go all the way across the screen, look. Do we go in there maybe? No, we don't. We have to go round. Oh, that's so unfair. Where am I? Oh, I'm not there. Oh, look at that. Yeah, it's like really hard. I'm determined to get off that first bit. What I can do is get the piece of heat shrink over there. Yeah, so there we go. It's not perfect, is it? But it's as good as I'm going to get that. And it's, you know, it's pretty sturdy, but you wouldn't want to flex it in a hurry, that's for sure. Yeah, there we go. So we've still got enough exposed. It's just a bit of protection for it, really. That's all. So I think this board now needs a good clean up actually. Let's just remove the keyboard adapter there. We've covered quite a lot in this first two parts here, so that yeah, there will be a part 3. Alright, the underside's had a good clean, but you can see here it's filthy on the top side. So yeah, I'll just flip past this I think and show you the end result. Give you a look over the board first. Yeah, so you can see it's still a bit dusty up there. The modulator needs that blob of soldering back on. That's the only thing I haven't done since I borrowed it from the other board. But anyway, I'll give you an after for you. So we need to get a custom BIOS and just program that with... stick it up there, I always forget the name of that programmer. The other thing we're going to need to do here, I think, let's just do it now, because this ROM is modified so you can use the disk drive, I think. The ports are differently. I think there's like 5 or 6 bits on the 6510, and there's like a few more bits, I think at least one more bit on the 85 or 7501. So yeah, we need to have a modified ROM to do with that, and a diode if you're going to use the tape stuff. Now I assume with that modified ROM the tape stuff will still work. I'm not sure if it's been modified in such a way that you can use the disk drive but not the tape, I don't know. We need to bridge that point there, I think, the tape motor, and then we're going to stick a diode underneath, maybe a resistor or something. So I'm just going to bridge that, get that in, and then just test it with the SD to IEC. Now handily, freeing up this kernel means I can use this kernel on the board you'll see in the next video. So let's take the kernel out. I think that's the kernel, yeah it is, I vaguely remember putting the test ROM in there. But you see I've been working on and off with this board with many other things in between. So let's get this ROM in. Pin 1 is to the left. Obviously I need to cover the EEPROM window up there. I think just for the moment I might just stick something over that actually. I can't think what. I think we'll just stick that little chip there, just because the lights here may be generating some ultraviolet. Anyway, so yeah, the next thing is to solder that point. Again, preparation. This is one of the things you should perhaps do before you solder your socket on. But you know what? I like to make my life complicated. I've got to be careful not to touch the blooming socket. Now the nice thing with this is these pads are really close to each other, so if we just hang on, try and not melt in the plastic here. Just get copious amounts of solder on both pads. There we go, we've bridged them. And again, I think it works this way. I hope so. It's ages since I've had that chip in there. Right, let me power that on, see if that does anything. But anyway, it has booted up with the replacement kernel there. So I'll connect up the SD to IEC. Yeah, balancing a ROM like that isn't a good idea, but you know what, I just don't want that getting wipes. So let's switch that on, just see what happens now. Yeah, got power there. Right, so we've got the C64 keyboard with our adapter, we've got the SD to IEC with the Datasette adapter, we've got a 6510 with a custom BIOS, custom kernel, and we've got an alternative, PLA replacement here, the one from Daniel, and it's 64K. Right, let's just see what happens. Load. It's hitting the drive there, that's working. Hey, it's brilliant, it's working, there we go. So we're using 6510 and the disk drive is working. And you can see that there. If I go down to the next directory, I press return, see it flash. It does get confusing using a C64 keyboard because the cursor keys are on the top row towards the right hand side, aren't they? Wow, that took blooming ages to load. Like, I don't know, a minute and a half, 2 minutes, probably 2 minutes actually. Yeah, so I've got the title screen up to press space. Hey, you'd think you're on a C64 looking at that. Yeah, it looks like it's cursor keys actually. So I don't know whether there's a key you can press to get the joystick working, but... So just testing another one here. This is Pac-Mania. Is the joystick... Oh, there we go. I was going to say, is the joystick going to work? Yeah, hang on. It's not the way I expected it to be though. Is it one of these where you've got a joystick on its side? Yeah, using the other joystick here, the other ports, that's working. So whether there's a problem with the first port, I don't know. I don't think there is. We'll try another game that I do know. Hang on, where have we gone? That works with the other port. Maybe go invisible getting uphill. See that? That's, yeah, you get the H and you go invisible. Ugh. Yeah, the joystick is working fine there. I think it's just one of those things where the ports are used differently in different games. You know, you can think it should be a certain way when it isn't. What I mean is you can think it should be in the first port and you need it in the second. And in that last game, just pressing a direction on Pac-Man, pressing a direction seemed to start the game, but only two of the directions worked and they weren't going the way you pressed. So if you're pressing right, you were going up, and down was going right, or something like that. It was a bit strange. But nevertheless, in this port that this game's using, it was working, and it's working here. So I guess I need to test the other port, but you know what, I'm sure I tested Ikari Warriors on here before, 2-player, and all directions working for both players, so yeah, we'll call that a success. So I think the next thing we need to do is get that diode under the board and test the datasette. Right, this is on the Hack Junk website. I'm not sure if that's the original creator of this mod, but nevertheless, he's got a nice picture there that shows me exactly where to fit it. So it wants to go to the third of these components here. I think that's like a ferrite bead or something, probably. We can see in a minute when we look over the other side, but yes, the third one there, cathode of our diode, 1N4001. If you've not got a 4001, a 4002 would probably do. That's it. Make sure it's obviously not bridging to another point there. And then we need to route to the third point down here, so I'm just going to bend it slightly, like that. Yeah. It's going to be soldered down there. So I'll just trim the end off. And we want a piece of heat shrink, so I'm just going to size that up, I think. That's probably going to be long enough. Yeah, there we go, that'll do. And then obviously we can shrink this once we've soldered it on, so let's just move it out of the way a wee bit, and assign a little bit of solder to that third point there, and some more solder onto here, and let's push the diode down into position, and join it up. There we go. Let's just hang on, try and hold it in place and add some more solder. It's going to flick back up. There we go. I knew it was going to do that. It's one of the consequences of it being the way it is. If I try and bend that leg down a bit, it doesn't matter if the heat shrink shrinks while I'm doing this. Hang on. There we go. We've got a sufficiently large solid point on that, and we can just press it down to make sure it's in position, and it is. So let's just clean it with a cotton bud there, get the hot air, shrink that. 150 degrees here. It's going to overshoot to start with. Too much heat there won't be the end of the world. It'll just shrink quicker. I will just measure on continuity test, make sure I've got the anode cathode right way around. Cathode is towards the tape connector up here, another little mini din, and the anode goes down to the IC. There we go, that ain't going anywhere, is it? Right, so a bit short on space here. The datasette there, connected up via our adapter. Everything is connected. Obviously we haven't got serial connected at the moment, and it didn't explode or anything, so that's a good sign. That's a good sign. Obviously you can play and stuff, so everything's working there. Fast forward, rewind, play. I'll finish cleaning the top side of the PCB in a minute, but you can see I am getting the board back in. So I've got two more screws here. These are the actual screws that came with the case here. So yeah, I'm waiting for a side panel here, you know, the cover. Sparks UK said he's got one of those, so that's really, really good. Where's the last one now? It's here, isn't it, I think. So yeah, it's nice, and the standoffs here feel like they're in one piece. So that's really good. Bear in mind, I'm going to be cleaning around with the cotton buds further afield because I didn't completely clean this. I focused a lot sort of in between the chips here, some of the stuff down here, and some of the stuff up here. So there's all this area here really needs a bit of a scrub. But you know what? That's not looking bad. Yeah, so I'll report back when that's here, and I'll just show you that fitted. I think there's nothing really worth taking this back to pieces to show you that. Yeah, ground goes in the middle, doesn't it? You can't get that round the wrong way. And the keyboard. Pin 1, now let's try and twist this the right way so it coils up inside. That's it. Unlike the C64, it hinges at the back here, so start with the back and hinge it into place like that. There we go. So there's a few bits of dust and dirt on this, need to get off, some flecks of paint stuff up here. We do have that crack there, I might try and deal with that in a minute. I'm just going to try and maybe get a little bit of acetone there, but I'm going to melt it on the inside just so that doesn't become a source of failure. Right, thanks ever so much to Sparks UK. He sent me this cover for the ports there, so this will make this one complete. So I'm just going to give this a gentle clean here, being careful not to rub the print off. You want to be careful with things like that because that white text will just erase really easily with too much pressure and polish and plastic cleaner and IPA, etc. So yeah, gentle clean, get that fitted. We've also got some tapes. So yeah, don't expect great games here. I just got a job lot from eBay that had, I think, 4 or 5 maybe C16 cassettes. So we can give this a final test there with the Datasette. Yeah, I had some of these tiny toty screws here. I don't know what they are. They're not metric, but they screwed straight in there and hold that nicely in place, and they're really short, so that will do the job. So I've got 3 heat sinks there onto the 6510. They still get hot, just like the 7501 or 8501 would. I'm guessing the 8501 is going to be more reliable. It was just a different technology to the 7501. Originally, I think when I first pushed that video out, part 1, I thought it was a PAL NTSC thing, but no, it's not. The CPUs, I think, are region free. If you think about it like that, they're not. There's no relationship to the clock stuff. It's all the divisions and things are done probably by TED or something else on here. You could argue get 4 of these heat sinks here because it's so much wider, but 3 is going to be fine in the middle there. It's just going to help dissipate some heat. Now these ones came with their own thermal tape, so I'm just going to test these to see. Yeah, that's going to be alright, they're going to hold in place. Yeah, see how reliable that's going to be in terms of transit. And I may just do that before I ship it out, is just unscrew the head, just make sure, try and pull one. If you can lift the thing up like that, it's going to be firm enough. If you can't and it pulls off, it's just not going to survive transport to somebody who buys it. So let's get the bits of dust out there and we'll get back together. Let's test the tapes. Right, so I've finished cleaning up the back end up here, and I marked it up fixed 2022. That little label's not very straight, but it doesn't really matter, does it? So just make sure everything is in firmly. Yeah, no chip creep there. Get the keyboard back on and let's test the tape stuff. So let's rewind. That's the disk drive. Star. Press play on tape. Right, it detected we press play, so that's good. Let's just see what happens. Now these tapes are untested, so no idea whether it's even a good tape. Found Scramble C16, there we go. And it did pause the tape, I think, there. So I'll report back whether we're, oh, hang on. I'll report back when something changes. I saw something briefly there, I don't know what it was. Maybe we'll get a loading screen, maybe the game will just, load upon completion. Well, the next tape I came to test here is Spectipede, and this is quite revealing. And what I mean by that is, it does seem to relate to the timing thing, because it can't stop the tape, certainly with this game. Because what would happen is, you press play, you press load, and then eventually it would come with the title of the game. But then it would throw you to the prompt saying ready. And I was like, maybe I'm not loading this right, so I just type run, press play, but it would do nothing. And I'd rewind the tape all the way to the beginning, press play again, and then it would flash a few times as if it's trying to find a block and it's found the wrong block, and then it's continued all the way to almost the end of the tape, and then the game's loaded. So I think that it's it's missing the block. It's not stopping the tape at that point. I hope you understand what I mean, but anyway, that does seem to work, doesn't it? So it's Z, X, K, and M. I don't see a fire button or anything. Let's just try that keyboard. So this is a Mastertronic game, I think. Where are we? Oh, we're at the bottom. So it's like a cross between Grid Runner and Centipede, maybe. think you have to get the X, do you? God, that's a long death sound, isn't it? It took forever to load as well, by the way. Like 8-9 minutes, maybe 10 minutes. So I think you have to get... No, you don't. What do you do? Honestly, God, I do not know what you do with this, because I didn't see any fire button. What on earth did I press to fire? Shift. Right, so it's KM shift. Okay, right, here we go. Yeah, so it's like Centipede and Grid Runner. Well, that's actually not bad. Anyway, that's that one. At least one tape works. Let me try another one. God, that sound is really annoying the amount of time it goes on. The exact same problem happened with this game as well, where it seemed to miss, the next block. So I just rewound it a tiny bit, press play, and it loaded all the way through. And I had to press run because it loaded like the loader at the start. It didn't automatically run itself. So I don't know. Please post in the comments down below how you're supposed to load some of these, certainly the Mastertronic ones. Is it just load? And then normally would it stop the tape for you and say ready, and then you would have to press run? Is that in the instructions? Then it will load the remainder of it. It just seems weird to me. I would have thought that the initial loader block would run itself, not wait at the come back saying ready, where you would have to press run, and then it would continue playing the tape. So yeah, that's two so far that do actually work. Hang on, let's just press play on tape again. Well, maybe it hadn't loaded. Maybe that was just like a loading screen. Now, this is a loader I was about to say I can get on with, but look, it's messed up, isn't it? It hasn't loaded. Yeah, it's Nova Loader. So, yeah, I think there's a problem there. I think actually that should be some sort of title screen, maybe. So, I don't know, I'll report back. This obviously one, has got a problem as well. Maybe I spoke too soon, actually, because that did actually load. Despite the weird loading screen, so maybe that was normal. I've not got a joystick plugged in here. Nevertheless, that is actually working. God, it's awful compared to the C64 version, isn't it? And Galaxians has loaded as well. This is one of these ones where the label is missing off the tape, but I've got the label here. Spacebar to begin. I think I loaded this one from disk actually. I'm trying this. Yeah, so that works fine. It's like ZX and shift. Well, it's good that I've got some of these tapes working. Good God, that was moving a bit quick. It's hard to know what to stick this down with, actually. This is the side that had the glue. You can sort of see that in the light. So, yeah, I might as well stick it back down. I'm just going to use some of this rubbery glue here. Position there. Yeah, that's almost sort of central. I think the fire button, there you go, fire button's not reaching. Yeah, I'll show you what's happening here. This, because of this housing around here, it's not going all the way in. So if I push it really hard, there we go, makes a connection, and all the buttons work, I think. So getting towards the end of these tapes now. This, as you can see, is dirty C16 den. It sounds like a horrible place you wouldn't want to go to, where there's loads of like seedy C16s around. Anyway, that worked. This is quite a quick load as well, another Nova loader. It's dirty den, by the way, not dirty C16 den. That's the way I read it. Let's see if we can hit fire. Is this joystick adapter not reaching again? Let's press key. Yeah, that adapter's not working. Where are we? I think the answer is there. So, space fires. A jumps. I'm so glad I didn't have a C16 back in the day. I know a lot of people have got a lot of fond memories of these. What is that? Oh, an elevator. I didn't do anything other than just secure the inside here with a little bit of epoxy. So, you know, I haven't touched that mark there. I might revisit that. Obviously, this sort of brings part 2 to a close. But there will be a part 3, maybe a part 4. I'm not sure, because I've still got quite a lot of stuff in the next videos, you'll see. So it was great that we got this up and running, and obviously it works properly now with tape and disk drive, despite the fact we've got a 6510 in there. But there is that issue where it's not capable of stopping the tape. You know, when the tape plays, just like the C64, the computer can stop the cassette deck from playing. Yeah, so at a certain part in the loader where it wants to pause for a minute before it does some decompression or something, or runs some code, and then continues the tape playing to load the next block, it doesn't stop. So you've got to be really on the ball if you're trying to load cassettes. Out of about, I don't know, 12 cassettes, 5 or 6 of them, or 7 or 8 of them, I managed to get to load by noticing the computer to stop, it's doing something on the screen, and just stop the tape, and then wait a second or two, press play again, and it would continue and load okay. But disk drive just works totally normally there, so there's no issues there. So yeah, huge thanks to Sparks UK, Daniel Mantione, Lotharek, Alex, as you'll see, we need the TEDs he sent for the next video. Dave Curran from Tynemouth Software, there'll be a link down to his blog below for the RAM. It just assisted me working out which address bits I needed there. And if you think about it, actually it was logical. It's the upper 2 address bits. It's a 16-bit address bus on the 6502. So yeah, it kind of made sense, but it might not have been. You never know. They could have mapped it in such a way that it was like some of the other address bits that weren't used. But yeah, that wouldn't have made sense, I don't think. So yeah, it's the upper 2 address bits. Anyway, I do hope you found the video interesting. If you'd like to support the channel, please leave your coffee and Patreon links down below. I'll catch you in the next video.